In this video, we will look at the Maclaurin series. Alright, so we have this question. Here it says find the Maclaurin series for sine x. So the Maclaurin series is just a special type of Taylor series where it's being evaluated at a point where a is equal to 0. So in the function where there's a or where there's x, we're replacing it with 0 and finding the general formula for that Taylor series. So that special type of Taylor series is called the Maclaurin series. So we have this question. So how do we go about this question? So in order for us to solve this question, we will say, first of all, our f of x in this case is sine x. Then we have to evaluate this point at f equal of f of what? F of 0. And this is going to be, so where there is x in this function, we replace 0. But sine 0 is just going to be equal to 0. Sine 0 is equal to 0, so that will be 0. Then we have f prime of x, so we differentiate this sine x. So when we differentiate sine x, we just get cos x. Then cos x, so we're saying f prime of 0. So when we press 0 here where cos is cos, so cos 0 is just 1. So this will give us 1. Then we have f double prime of x. This is going to be, we differentiate cos x, we get negative sine x. Then this is going to be f double prime of 0 sine 0 just to gives us 0. So we get 0 there. Then we continue f triple prime, differentiate negative sine x, we get negative cos x. Then f double prime at 0, we replace 0 where cos is, that is going to give us cos 0 is just 1 multiplied by that negative, we get negative 1. We do this again, we go to the fourth one, and we just get x equal to, so when we differentiate cos x, this gives us negative sine x. But then in this case we have a negative outside there, so when we differentiate that negative, we multiply and you just get sine x. So here negative cos x will just give us sine x. Then this here is going to be equal to 0. So this gives us 0. Yeah, then we can continue differentiating this and this all the way up to continue. We realize that we will have an endless cycle where we are just going to be getting 0, 1, 0, negative 1, 0, then it will go again 1, 0, negative 1, then again it will go 0, 1, 0, negative 1, just like that. So it's going to be repeating in that form. So from here we can write and say, so if we have f of 0 like that plus f prime of 0, then x, so this part we only have x. Remember, if we have a Taylor series, in general it looks something like, so in general it's going to be f of a plus f prime of a over, so 1, which is just 1 factorial like that, then x minus a, then this continues all the way up to what? Up to infinity. But now here we've replaced our a here with 0. So when we place here where we are, of course our a in this case we're saying is x, so we place there, we just have a minus a, and this gives us 0. Okay, here where there's a, when we place 0 there, we just have x minus 0, and we just get x remaining. That's the reason why here we're just having f prime of 0 of x. So that part there where we have x minus a to the power something, this here is going to be 0, so we're just going to be having x to the power n in general. Okay, so our function then will continue from there. It's going to be, so that is divided, saying that is divided over 1 factorial. Then you have plus f double prime of 0, that will be x squared divided by 2 factorial, because we're evaluating it at what? At a, at our a equal to 0. So as I said, the x minus a there to the power n, and I just have, so that will be x minus 0 to the power n, and that will be x to the power at n. And as we can see, well, that is, well, number 2, because this is double prime, so x there is going to be x to the power 2. Yeah. So we continue from there. We can go f triple prime of 0, that will be x cubed, then over 3 factorial plus, and this continues all the way to what it continues. So now, replacing what we have in this question, so we already have our this part, we already have f prime there, we have all these f double prime, and that, what are we going to get? So if we were to replace, so the first one, we're saying the first one here, we see that this part here gives us what? 0. So when we place there, we will have 0. Then we go on the next one, f prime. We have f prime, there's what? There's 1 there, so that's going to be just x, that's going to be plus x over 1 factorial, which is just 1, and that is going to give you just x. Then the other one, here we get f double prime of x is what? Is 0, so you have, that will be plus 0x squared over 2 factorial. Then that can continue. You will have that the one that follows is going to be negative, of course, because you have negative 1 there, negative 1, and that is x to the power 3, of course, over 3 factorial. Then you go on to the fourth one, it will give you 0, so that will be 0x to the power 4 over 4 factorial. Then the one that follows is going to be plus, it's 1, so that will be x to the power 5 over 5 factorial. But this then continues towards it to go on forth like that. So if you observe, if we remove the parts, because this part here gives you 0, this one gives you 0, and when you add, you just remain with the ones that have the values. So the first one will just have x there remain, then we have minus x to the power 3 here will remain, because this one just gives us 0, x to the power 3 minus 3 factorial. Then I'll have, that gives me 0, then I'll have plus x to the power 5 over 5 factorial, then minus x to the power 7 over 7 factorial. And this continues to go like that up to infinity. So now I must come up for a general expression of how I am getting these terms here. So of course I know it's a summation, because this is a series summation from n equal to 0 to infinity. So meaning this first part here, I must be getting it when n is what? Is 0. I must be getting it when n is 0. This part here, I must be getting it when n is 1. This there when n is 2. That there when n is equal to 3. Then all the way going up to there. So I can see that my sign is alternating. Here I have positive, there I have negative, positive, negative, like that. So meaning I must have a part where it is alternating. So I have negative 1 to the power n, like this. So here if I put in, when I put in 0, so when I put in 0 here, I'll have this negative 1 raised to the power 0 gives me positive 1. so I have a positive value there. For the next one, when I put in 1, negative 1 raised to the power 1 will be negative 1. I'll have a negative there. Then here, when I put in 2, negative 1 raised to the power 2, that is going to be negative 1 by negative 1 gives me positive. I'll get that positive there. When I put in the odd power 3, which is an odd power, I'll get negative. So this here, the first part, to satisfy the sign which we are going to be having from positive, negative, positive, negative, just like that. They'll be going up to infinity. Then I must now consider this x variable. So the x variable, I have that when here the first one I just have x, then it's going in what? In odd powers. So from this is 1, then it's going 3, 5, 7. And there's a what? There's a difference of 2 between the odd powers. So meaning I must have 2, of course, like that. Then when I add this, when I add plus 1, this then becomes odd. So this is even, then it becomes odd. So we're saying the difference between the numbers is even because they have a difference. The difference is 2 in the numbers. From 1 to 3, the difference there is 2. From 3 to 5, the difference is 2. From 5 to 7, the difference is 2. So they are moving in what? The difference between them is even, so I write 2n. But then, what am I getting in the powers? I'm getting odd numbers. 1, 3, 5, 7. From 7, I'll get 9. I'll get 11. So it continues to go just like that. So meaning for this even number to become odd, I must add plus 1. So there I'll put n plus 1. And I can check here when the first part is when we're starting from n equal to 0. So when we replace there, we get here, we know anything raised to the power 0 will get positive 1. But when we place where x is, so this is multiplied by x, we replace where n is, we have 2 multiplied by 0, which will give us 0 plus 1. And this is going to be x equal to, the power is 1, so I can just write this as x like that. Then I can do the same again. I can replace when x is 2. Let's say when n is 1. The next one is when n is 1. So when n is 1, I'll have negative 1 raised to the power 1. Then I have x 2, where there is n, I replace 1 plus 1. And I'll get negative. Then this will be x like that. Then 2, here I'll get 2 plus 1, then I'll get 3 with a negative there. So I'll be getting these odd powers that I'm getting. So I've covered that part of it. Now we consider the factorials down there, the numbers that are being divided. And usually what you have in the power there is what you just put in the denominator for the factorial. So that will be n, 2n plus 1 factorial, like that. So you see, for the first one, replace 0 there, you just get 1 factorial, which is 1. The next one, when you replace 1, you just have 2 multiplied by 1, then plus 1, that gives you, and there's a factorial there, that then gives you 2 plus 1, then factorial outside, and this will be equal to 3 factorial. So this here is going to be the general form of this sign, for this sign, for finding the Maclaurin or for sin x. So this is going to be the general form for finding the Maclaurin of sin x. So which means sin x, Maclaurin is just summation like that from n equal to 0 to infinity. Then I have negative 1 like that to the power n, then x to the power 2n plus 1 divided by, that is just 2n plus 1 factorial. Alright, so this is how you get the Maclaurin series.